Welcome you all for my next GATE video series. So myself is Krishnaveni, Assistant Professor, Department of Information Technology, S.A.ENG.COLLEGE. Today we are going to discuss the topic of searching under the subject of algorithms. So first we are going to discuss about what is searching and also why searching topic is so much important in GATE examination. So searching as a term itself, we can identify why we are going for the searching. The process of finding a specific element within a collection of data. We are having a collection of data in the form of different data structures such as array, linked list, tree and graph. From these different data structures, we are going to find out a particular key elements using the concept of searching. Okay, so the search can be successful. When it can be set as successful means the particular element should be find out in a given data structure. Then that should be set as successful or unsuccessful. That means element is not found in a given data structure. So what is searching is a process of finding a specific element within a collection of data. There is a collection of data in the form of different data structures. So next, why it is important for GATE? So searching is the fundamental concepts under the subject of data structures and algorithms. Without algorithm, we cannot do any designing of data collections. So it forms the basics for more complex algorithms for searching and sorting. Questions related to searching algorithms based on time complexity as well as the space complexity of each and every searching algorithm is giving more important while answering the questions in the GATE examination. So what searching is so much important under the subject of algorithms. So next, types of different searching algorithms. Searching algorithm is broadly categorized into two types. First one, sequential search, and second one is interval search. Sequential search means check each and every elements one by one is linearly. We are concentrating each and every elements in linear order one by one. This is called sequential search. Second one, interval search. Interval search means we are efficiently narrow down the search space. So we are going down, it's like if you are going to take a tree, data structures means we are going down. Down means we are traversing till leaf node to find out whether my key element is found or not. This is called interval search algorithms. Key algorithm we are going to discuss for this video series is three main algorithms. First one is linear search, second binary search and third hash algorithms. So first concept, linear search, as well as it is called as sequential search. The main concept is it is a simpler search algorithm. It sequentially check each and every element of the list until the match is found or the entire list has been searched. This is the linear search. It does not require whether the data should be ordered like a sorted or descending as well or otherwise descending. It may be in any form. It may be sorted or otherwise it cannot be sorted. This is unsorted element also can be searched using this linear search algorithm. It is very simplest algorithm. You just traversal starting from beginning to end. So algorithm, very simple pseudocode. So we are writing the function for linear search. We have a two components. First one is array. Array means it is a collection of data in one data structure. This is array. It having some key value. Key value means it is our key element we are going to search in the given array. So for I from 0 to array dot length -1. This is our last element in the array. So if array of I is equal to key, if I am starting from array of 0, it consists of the number 1. If it is my key value means my element is found. Otherwise the for loop should be continued till my key element is found in a particular array index. It is the pseudocode for my linear search algorithm. So each and every algorithm Mostly we want to concentrate on the analysis part. Algorithm writing is so easy, and also we can carry out the implementation part also. But most important part of this algorithms is analysis. Analysis means how the algorithm should be give more successful in taking very less time and space. So very important topic is time complexity and space complexity. So analysis, we are concentrating time complexity. We have three cases: best, worst and average. For this linear search, best case having the value of big O of 1. Big O of 1 means the element is found at very first index value of an array. This is the best case in linear search. Worst case, big O of n. N is the number of elements in the given data structure. When the element is the last, it may be in last or otherwise it's not present in the given data structure. Average case, big O of n. This is the time complexity. Next, space complexity, big O of 1. It is in place algorithm. So this is the use case is best for small and unsorted data set. So linear search is very suitable for only small set of data, as well as that should not be in sorted order also it is applicable. This is linear search. Second, we are going to discuss about binary search. It is under the category of interval search. I already discussed the two types of searching. One is linear, this is sequential order. Second is interval. Under interval search, we are going to discuss about binary search. Binary search, it is a very highly efficient algorithm, but condition is here the data should be arranged in sorted order. It is sorted only we are going to apply this binary search algorithm. But in linear search we can go even sorted or unsorted. But in binary it is so much important to concentrate the given elements arranged in data structure should be in sorted. It works on divide and conquer principle. So it repeatedly divides the search interval in half. So the concept behind this binary search is how many elements we are having. You should take a middle element, you should divide into two half. Then you start search starting from left. If it is the particular element is found in left side, then the right hand side you don't need to going for searching. If it is our key element is higher than given element, means we are going to the right hand side element and find the searching. If it is found in left side, the matching should be occurred. So how it is worked? This is the algorithm steps. First, start with the entire sorted array. The element should be ordered in sorted way. Find the middle element. Compare the target value with the middle element. Then next step, if they match, the search is successful. I am finding my middle value. The middle value is equal to my key value, means my binary search is completed. Yes, I found my value. If it is not found, means we are going next step. If the target is small, continue the search in the left hand side, or if the target is larger, you continue the search in the right half of the elements. No need to go left hand side. So because of this concepts, we can achieve good time complexity as well as space complexity while going this binary search algorithm comparatively other algorithms. Repeat until the element is found or the interval is empty. So this is the process of binary search tree. Binary search tree main concept is divide and conquer. You should divide the total number of elements in a particular data structure into half. This is the concept behind this binary search. So next part very important, I already told you, analysis. Most of the questions for this GATE exam came under this topic, analysis. Time complexity, best, worst and average case. Best means big O of 1 when the element is in the middle. When I am dividing my number of elements into half, the middle part is my key element, means my searching is completed. It takes very less time. This is the best part. This is best case, big O of 1. Worst case, big O of logarithmic n. Average case, big O of log n. Okay. Space complexity, big O of n for iterative implementation. big O of log n for recursive implementation. Okay, 2 space complexity, one is recursive, one is iterative. So iterative means big O of 1. This is recursive means big O log of n. Here we can use the use case in the form of highly efficient for large and sorted data set. So linear means very small and unsorted data set, but binary highly large, efficient large data set. This data set should be in the form of sorted. So next topic, hashing algorithms, hashing and searching. Hashing we are using 2 terms, one is hash value, another one is hash function. So hashing provide a way to achieve average case of big O of 1 time complexity. It's a middle case, it's not a best, it's not a worst. It is under the case of average big O of 1. So we can achieve insertion, deletion, whatever operation, we can achieve the average case time complexity. So here we are using hash function. What is the important for this means to map a key to a specific index in the data structure. So how I can index my elements into a particular value in array. There should be a value of hash function. So hash function that takes a key and returns an index. So they based on the key element hash function to calculate the hash value. This is our index value. Based on this index value, the key value should be fixed. This is arranging the elements in a data structure based on the index value. Index value is our hash value that should be calculated by using the hash function. So this we can discuss later in gate questions. Okay. This hashing we have one problem. This is collusion. What is collusion means? The situation where 2 different key map to the same index. If array index of 5, for this 5 index, 2 key values 5 and 10 can match the same index value. That's the time the collusion should be erased. How we can eliminate this collusions means we have using the linear probing technique, discrete probing technique or chaining technique. We can eliminate this collusions in hashing function. Search algorithm, then its analysis, average case time complexity big O of 1, best time complexity big O of n, space complexity also big O of n. Average case means for successful and unsuccessful search both having the good hash function value. Then worst case when all key hash to the same bucket. I already told you we have the collusion problem. At the time of collusion problem we have the worst case time complexity. This is big O of n. Okay. So this is the comparison table for these 3 searching algorithms. Complexity, this is analysis part. First algorithm linear, second binary, third hashing. So data requirement, I already told you linear search we can handle both unordered or ordered. So unsorted or sorted both can handle by the linear search. Binary search, it is very important. The given array elements must be in the form of sorted. Hashing, this is not applicable. It is based on calculations hash value. So best case, worst case, average case, we are calculating time complexity as well as space complexity big O of 1, big O of n, big O of n and big O of y1. This is all for linear search. It is a comparison. We have to know about this table very clearly. It may comes under the multiple choice questions for this searching and algorithms. So next we are going to discuss following 10 questions under searching concept. Okay. So first question, what is the worst case time complexity of searching for an element in a balanced binary search tree with n nodes? So this is the concept under the binary search tree. Here we are asking about the worst case time complexity. So worst case, this is the worst case time complexity. Binary search, here we are having the value of big O of log n. So the right answer is big O of log n. A balanced binary search tree. For example, if you are going AVL search tree or red black tree, ensure that the height of the tree is always the logarithmic value. That should be take this. So worst case complexity value is big O log of n. So right answer is big O log of n. Second question. Yeah, we are discussing about the hash function and hash value. Yes. So here we are going the problem related to this. Question is a hash table of size 10. We are having the hash table, the size of 10 elements we can include. We are used to store 6 items. Size is 10, but we are going to store 6 items. The hash function is used as h of k is equal to k in bracket mod of 10, and collisions are resolved using linear propping. The question, sometimes we are calculating the hash value function, but while you are going to indexing a particular key element into the array, that's the time we can facing the problem of collision. So how we can avoid this collision function? By using the technique of chaining, linear propping, discrete propping. So in this question they are mentioning linear propping. Linear propping means if, for example, the index 5, they have 2 key elements, then we can go with the next free index element. This is 6. This is linear propping. The items 4, 12, 23, 10, 24 and 5 are inserted in that order. What is the final state of the hash table? So the explanation, first we are starting with the key value 4. So the k is equal to key is equal to 4, h of 4 is equal to 4 mod 10. So the index value is 4. So first element is 4. The fourth element should be fixed in the index of 4. Next value 12. So 12 mod 10, the value answer is 2. At the index of 2, we are going to insert next second element is 12. Third element, this is 23. This is my key value. So h of 23 is equal to 23 mod 10. The answer is 3. So index value 3, we are going to insert our third key value 23. Next 10. So value is, index value is 0. At the index of 0, I am going to insert my key value is 10. Again the next term is 24. So 24, at this formula, the value is 4. So again here index 4 is already occupied by the first key value 4. So here the problem of collision should arise. Yes, collision arise, but in question already they are mentioning the solution is linear propping. So index 4 having the collision problem of 2 key values, one is 4, another one is 24. So here what we are going to do, the next free index value is 5. This is empty. So you are going to insert 24 at index value of 5. So my 24 value is going to insert into the index value of 5. So the next key value 5. So h of 5 is equal to 5 mod 10. The answer is 5. So just now only index 5 inserted the key value of 24. So 5 is already occupied. So here we are having the problem of collision. By linear propping, my next empty index value is 6. So I am going to insert my last key value 5 at the index of 6. So the final hash table is 0 index 10, 1 nothing, 2 12, 3 23, 4 4, 5 24, 6 5. This is the 10 size hash table, but we are going to store only 6 items based on my hash function. Okay. So my hash table structure is 10, 12, 23, 4, 24, 5. Collision problems arise, but we are rectified using the technique of linear propping. Hope you understand this problem. So next problem, the best case time complexity complexity of a linear search algorithm of an array of n elements. So big O of 1, already we are having the comparison table values. The big O of 1 is linear search algorithm, best case. Okay, so the next question, which of the following searching algorithm works best for the list? This is already sorted. Yes, sorted means immediately in our mind binary search tree, because we know already linear search tree, it can supported both the sorted and unsorted. Binary search tree only supported by sorted array elements. So sorted means binary search tree only. So while both the linear search and binary search can work on sorted elements, so linear also supported, but binary search tree is significantly more efficient because it can eliminate half of the search space while comparing to the each element. If you are going linear means you have to traverse the whole element starting from beginning to end. But in binary search we are dividing into two halves, so our time and space complexity should be reduced comparatively linear search. So best advisable while going with the sorted array elements means binary search tree. So the answer is binary search. So the next question, the recursive binary search function has a regression relation, some value. What is the space complexity? Here recursive. So in our table, comparison table, we already discussed space algorithm for this question. Yes. For this analysis, big O of 1 for iterative implementation, big O log of n for recursive. So binary search, they are asking two different types for space complexity. If it is recursive binary search means our space complexity of big O log n. If it is iterative function means you have to select big O of 1. So for this analysis, you give such more importance for each and every part of analysis. This is complexity, space or time complexity. So the answer, if it is asking recursive means answer is big O log of n. So the next sixth question, the hash function's formula h of k is equal to k mod 5 is used to insert the keys 15, 20, 25, 30 and 35 into the hash table the size of 5. So what will happen? So we have lot of choices while you are going to insert the elements into the hash table. This is the problem of collisions. So here we have 4 options. First one, all keys will be inserted successfully with no collision. Without any collisions, I can insert all the elements. First choice. Second, the first key will be inserted and all subsequent keys will result in a collision. Only one element will be inserted, others having the problem of collision. That's the second one. There will be multiple collisions which can be resolved with the chaining. Chaining is also one of the technique for collision problem avoiding technique. Then fourth one, the table will overflow if open addressing is used. This is the 4 option. We will try which one is best. Okay. So explanation. First key value 15. So I have to calculate the mod value. This is 15 mod 5. The index value is 0. 20 index value is 0, 25 index value is 0. So each and every key value we are going to calculate the hash function, but each hash function having the same index value 0. How we can insert all 5 elements into same index? It is not at all possible. So collision is occurred. So since all key maps to the same hash value, a collision will occur for every insertion after the first one. So first one I am trying to insert index value 0. So at 0 I am going to insert 15, but other second, third, fourth key values while I am trying, collision should occurred. So the answer is the first key will be inserted and all subsequent keys will result in a collision. Okay. So the next 7th question, in a sorted array of n different elements, an element is searched using binary search. In the worst case, how many comparisons are made? So sorted means binary search tree. Yes. Okay. So here we are asking about worst case. Worst case, how many comparisons are made? Worst case means we already know about it. Log the power log of n, okay, this is the worst case. Binary search repeatedly of the search space. The number of times you can divide n by 2 until it becomes 1. Yes, log of n. This is the worst case. When we are going to divide until our last element should be arrays. So here the answer is log of n. This is our worst case. Then 8th question, which of the following is true about linear search? First option, it is efficient for large data set. So very initially I told you linear search tree means it is suitable only for unsorted, maybe sorted, but having a very small data set. Okay, so first option is not at all suitable. Second one, it requires the data to be sorted. No, it may be unsorted or may sorted. It's not necessary, you only go through with the sorted. So second option is wrong. Third one, it has a worst case time complexity of big O of 1. Then okay, in the worst case not big O of 1, this is big O of n. Okay, and then the last one, it works on both sorted and unsorted data. Yes, the last option is right. Both sorted and unsorted, we are going linear search algorithm. So 9th question, consider a search algorithm that finds an element in a sorted list. Sorted means binary search, okay, by repeatedly jumping a fixed number of steps. Yes, binary search tree, but it having some technology. This is jumping into a fixed number of steps until an element greater than a target is found. Then performing a linear search in the previous block. What is this algorithm called? Okay, so this describes the jump search. Okay, this is improvement over linear search for sorted array. Sorted array, we are even applying linear search tree. It is an improvement for jumping by jumping a fixed block size. This is n. We having a, if it is n value is 5 means we are jumping. We are starting from 0 to 5th element for comparison of my key value. Okay, find the block containing. So here the answer is jump search for the given scenario. It is also one of the improvement version of linear search. Then the last question, in a scenario where the search key is known to be uniformly distributed among the elements in a sorted array, which search algorithm is expected to perform the best on average? So here we are going to discuss the new term. This is interpolation search. Interpolation search is an optimized version of binary search. This is having the special quality of uniformly distributed sorted data. If for example you are going to sorted an data but you having a uniformity, for example you start 2 means 2 elements should be sorted 2, 4, 6, 8, 9, 10 like this. This is uniformly distributed sorted array. For this we are going to apply one of the improved version of binary search tree. This is called interpolation search algorithm. Instead of always checking the middle element, we use the interpolation formula to predict the position of the target key. It is a technique for prediction of my target key. This estimation helps it to jump immediately to my target value. So its time and space complexity should be reduced by traditional binary search tree comparative with our traditional binary search. So it is one of the improved version of interpolation search. This is binary search algorithm, and also linear search algorithm we having another one improved version. This is jump search algorithm. So today we discussed 3 types of searching algorithm. This is linear, binary and also hashing. So linear, it is a very simple and very little amount of data can be handled. Binary, it is an interval depth level of search space. So binary means we have improved version of interpolation search also. Hashing, it having two important value. This is hash value and as well as hash function. Based on this, we are finding out an index value. This index value, we are finding whether the given key value should be inserted or not. Here one problem should be arise. This is collision that should be rectified by using chaining, linear cropping and domestic values. Something we having lot of techniques to overcome this. So this is the topic we are discussed till now. So thank you to all listening this concept very patiently. So next topic we will meet in our next video. Thank you for this opportunity. Thank you all.